Hello everyone, here is Kostas, Sierra Victor 3, Oscar Romeo Alpha, and today I'm gonna do a small experiment with two types of lead-free solders, how they behave in the different joints, and what you would expect if you buy either of them. So the first type is the SAC305. It's the standard lead-free solder that is used in the industry. It contains tin on a percentage of 96.5, silver at 0.3%, and copper at 0.5. Sorry, the silver is 3%, not 0.3. Okay. Now this is the standard alloy that is used in the industry, and the other alloy is the I want to compare is the SnCxPlus07. This contains, let me take it out, the percentage that it contains. It contains tin and copper only, no silver addition. Okay. And the percentage of the tin and copper is, let me take this out, it is, yeah, the tin is 99.3% and the copper is 0.7%. Okay, so I'm going to compare these two. I have already preheated the soldering station to 550 degrees Fahrenheit. So let's see how these materials behave at this temperature. Okay, let's do the first test. I'm gonna clean the soldering iron from any. I'm gonna try first the SAC305 alloy, and yeah, the diameter is a little bit smaller than the other alloy I have, but it's okay. I'm gonna try this now. I'm gonna try to see if it melts at all. Let me get the camera zoom on it, if I can. Okay. This is how it looks like at 550 degrees Fahrenheit. A small blob of solder. I'm gonna put another small blob of solder. Okay. This is how it looks at 550 degrees. Now I'm gonna clean the soldering iron, and I'm gonna try the other alloy, the SnCx. This is the SnCx. I'm gonna clean the iron again and put another blob of solder as well. Okay, this is how it looks at 550 degrees. So I'm gonna put again a blob of solder from the SAC305 alloy, and I'm gonna leave it onto the iron for about 1 minute and see the oxidization onto the tip. Okay, it's been about a minute now, and I'm gonna show you the tip. That's it. No significant signs of oxidization onto the tip. Now I'm going to try the other one, the SnCxPlus07. I'm gonna put a good blob of solder onto the tip. And I'm gonna leave it for about 1 minute there also. Okay, it's been about a minute now, and I'll show you the tip of the iron. I can see no significant signs of oxidization either. So now I'm going to raise the temperature of the iron to 600 degrees Fahrenheit, and I'm going to do the same test again. So I'm waiting for the iron to heat up. Okay, it's already heated, and I'm going to try first the SAC305 alloy. I'm going to put a good blob of solder there. Okay. And I'm going to leave it again about 1 minute. Okay, so this is the result after 1 minute onto the soldering iron. No significant signs of oxidization. Now I'm going to do the same with the other alloy at 600 degrees Fahrenheit. Farad, sorry. Okay, so back in a minute to see how it goes. Okay, that's interesting. I don't know how well you can see in the camera, but there are some barely noticeable oxidization onto the iron tip. It can be barely seen. So I'm going to do the same test again at 650 degrees Farad. I'm going to clean the soldering iron, put some blob of solder of SAC305. I'm going to clean it again and put another blob. I'm cleaning it twice just to make sure that no alloys, that the previous alloy has been cleaned off the soldering tip well. And back in a minute. Okay, so after a minute onto the soldering tip, here's the result. Very, very tiny traces of oxidization can be seen. It's a little bit difficult to show it in the camera, but I think you might be able to notice that the surface is not so shiny as before. Now let's do the same test with the other type of solder, the SnCxPlus07. I'm gonna clean the tip twice. I'm gonna put the blob of solder there, and back in a minute. Okay, so here it is after a minute. There is clearly oxidization onto the tip, little bit reddish oxidization. Okay, and this is surface oxidization of the blob of solder. Now I'm going to increase the temperature even more at 700 degrees Farad, and I'm going to do the same test again. I'm going to feed the blob of solder from the SAC305 alloy, re-clean the tip, and I'm going to do it again. And I'm going to leave it there for a minute again. Okay, so here we are after a minute. There are some traces of surface oxidization, but not a significant deal with a SAC SAC305 alloy, and I'm going to do this again with the SnCxPlus07. Reclean the tip and do it for the second time. Okay, so back in a minute to see the results. Okay, after a minute, again some oxidization onto the soldering tip, but not a big deal compared to the previous, the 650 degrees. Yeah. Also, I think it's a surface oxidization. Now it's difficult to hold the camera while I'm doing this, but I'll try to scratch off the surface to see if the oxidization is, let's say, inside of the solder blob. Let's try a good focus point to the test. No, it seems the oxidization is happening only on the surface of it. Yes. Yeah. It seems it happens only on the surface of the blob of solder. So I'm going to do a final test at 800 degrees Farad now. First clean my tip, increase the temperature to 800 degrees Farad. Wait a bit for the soldering station to set. And feed the blob of solder of SAC305 alloy, clean the tip, feed another blob, and wait for about a minute to see the results. Okay, there's clearly some oxidization now. And I think it's surface also. Yes, it seems that it's surface oxidization. And the same test again with the SnCxPlus07. And this is how it is after a minute. No significant oxidization compared. Now, these tests show an interesting point. It seems that at 650 degrees Fahrenheit, and I say Fahrenheit because at the videos I mentioned Farad, which is wrong, okay, it's degrees Fahrenheit. At 650 degrees Fahrenheit, the oxidization seems to be much higher than